Um, okay. Yeah, that was interesting. You were saying about the overcompensation.
Yeah, so these intention tremors, like the type of kind of malfunction that they are, is a malfunction in feedback. It's like there's too much of an amplification of the signal so that effective like motion isn't possible. Because he talks about how like in some situations you don't get this tremor. I was like reading something else about this at the same time, so I can't remember exact. Maybe I'm talking about the other thing I was looking at. But yes, okay, postural feedback. I read that like Parkinson himself said that a sudden like reposturing, a sudden change in posture of a person with Parkinson's can temporarily like stop the tremors. Like the mechanism being this like full body, full brain reorganization. And it's only a temporary stop in the tremors. But yeah, I don't know.
It's like the riding the bicycle
Why I'm
thing.
finding this so interesting.
Yeah, like where did Norbert mention that last time? I feel like I just saw something about that. Did you mention that, Bradley, again in the we talked about that recently somewhere, right?
Yeah, we've talked about postural dynamics. I mean, basically, you can, if you're standing, and I think we talked about like where if you're standing still and you stand on a pressure plate, you can measure these oscillations in posture. So you're constantly moving back and forth and side to side to sort of, your muscles are active and, there's some output of postural sway. So you maintain your sway over like what kind of looks like Brownian motion around a center point. And then if you have Parkinson's disease or some other disorder, that those basically what happens is you're standing there and your muscles kind of twitch and you're moving around a center, your point of mass. In those kind of disorders, you're not regulating that. So it's kind of like you're swaying too far in one direction or another and it's very irregular. And so, you can draw dynamical systems like an attractor map of that, and it kind of looks like it goes all over the place. And your capacity for falling down, of course, increases with that sway. So usually healthy people have like they have a postural sway, but it's maintained around a center of mass very tightly. If you have a movement disorder, you can like kind of wobble back and forth and eventually you can fall down or worse. Now you can readjust your posture so that you can reset, I guess. I mean, that makes sense. So yeah, I mean, that's where we talked about it. Yeah.
Yeah, I remember that now. Yeah, so it's like there's a feedback system that's involved in trying to stay still. Like if you're trying to stand still, there's that wobble.
Yeah.
And it seems like in my impression of how Wiener talks about it is in Parkinson's disease, it's when you're trying to stay still that the tremor is worse because the kind of feedback involved in keeping you still, when that's like over amplified, you get this wobble or the tremor. And that's why, pursuit of a goal, goal-oriented motion, or just like like a full body motion, that explains why that can like temporarily alleviate the tremors.
Yeah.
Like a difference between the feedback that's involved in staying still and then the feedback that's involved in reaching for a glass of water.
Yeah. There's this other idea from back from the 1960s about feedback being explosive. So feedback isn't regulated, mean, if it's just kind of like what we might call runaway positive feedback, it can be explosive, meaning it can just kind of be kind of an explosion of activity as opposed to something that's controlled. So when you see something that's controlled that's a product of positive feedback, it's usually that, there's some other mechanism in there that's sort of dampening it at critical times. And so you get this sort of feedback where it's actually able to maintain itself. Otherwise, if you have unrestrained positive feedback, it can be explosive. And if you dampen your system too much, it can become just kind of like basically dead, I guess, around a center point. It's kind of my understanding of that. Yeah.
Be fun to tease apart parallels between that and like the bacterial growth.
Oh yeah.
Because I think about that a lot in the context here of like almost like environment that affords positive feedback could be run away, but then it just going, and then like it exhausts it.
Yeah.
Like that's something. Note to self, like what Bradley said and what I just said, and some. There's something about that, and like a core thrust of a major project I want to work on is about. I don't know what to call it right now than like systemic exhausts or like the way the resources of the environment are used and what sort of, is it regulatory or is it like countering and what happens to the exhaust? But that's a little too tangential right now.
Well, I mean, like counter means like, basically if you look at a lot of brain circuits, there's a lot of like, there's a sort of positive feedback, but there's also like where you go from one neuron to another and the neuron is inhibitory in the sense that it takes the input and dampens it. So you have these inhibitory connections along with excitatory connections. So when you have a seizure, it's where there's this cascade of excitatory neuronal activity instead of having inhibitory neuronal activity interspersed with it. So, that's something that isn't normal. Usually a seizure is just like one of these cascades of excitatory behavior. Everything gets excited at once. So it always is that balance. And you have these sort of counter elements in there that kind of dampen things down critically. Not universally, but just kind of at critical times.
So going on from Parkinsonism, we get to the moth and the bedbug. I don't know if you saw that part, Bradley, but it was kind of like right out of. I don't know if Radenberg references this or not, or like who kind of talk from each other, but it basically talked about little like phototaxis and.
Oh yeah. Where is that section exactly?
It kind of starts 165, I guess.
Yeah.
The two principal modes of action, one of which is positively phototropic, it searches for light, and the other is which, negatively phototropic, it runs away from light. Moth and the bedbug, or what would be like love and hate or something like that. He kind of talks about that for a while, and nothing we don't really already know, but it was
right.
I guess.
I see. He gets into where you have these sort of mutual feedbacks or counter feedbacks. So positioning mechanism for the rudder contains a second feedback, which may be considered as postural. So that's where you get this postural control. It's just like countering some positive feedback with maybe like negative feedback, or well, negative feedback isn't really the right word, but basically so that they're sort of or they're like mutually regulating. Maybe that's the word. And so, Yeah, this is where you get into like if you have these very simple sort of taxic behaviors, and it could be like chemotaxis or phototaxis, that it's sort of a tendency to go in that direction. And that's the simple behavior. And then the more complex behaviors are where, you have these other mechanisms that sort of regulate that. So if you have like multiple tropisms, or if you have different types of, if you have a circuit of any complexity, you're going to have this sort of counter behavior, or these rivalry behaviors. You'll see that in binocular rivalry, where you have two eyes and they're coming in and they're kind of regulating the common part of the visual field. So, you have the formation of inhibitory zones, and zones that are actually, they're mutually inhibiting, and zones that are not inhibited. So, I mean, there are all sorts of things when you get like if you go into a vehicle, if you get certain circuit sizes beyond a certain size, that you get these kind of more complex behaviors arising from very simple sets of stimuli. Looks like Gray Walters mentioned here too.
Yeah, he gets. Do you know him? I forget what he's like about.
He was one of the people, if you remember, building these kind of biomimetic robots back at the time when Claude Shannon was doing the same. So,
oh, we don't have Shannon in here.
Yeah, he mentions Shannon. He mentions Walter's machines. He says that the tropism machines. The United States Army Medical Corps has taken photographs of the moth to compare with photographs of actual cases of nervous tremor. That's interesting.
yeah.
Interesting line here too. We've included features other than inverse feedback, which gives us an explanatory and ethical attitude to the universe, as well as a purely tropistic one. I wonder what ethical means here.
Yeah.
The moth and Dr. Walter's further development. Yeah. What Amanda just said. I wish like Norbert in the book included like more subheaders, because I feel like there'd be a subheader here. Like there's a second class of machines.
Yeah, he could have divided this chapter into. I made a short list, like 4 different machines. So you have the moth and the bedbug as one, and then you have the next thing is this hearing glove. Or I guess that would exemplify this group of machines that could aid when someone's senses aren't there's a deficit in one or more sense. So the hearing glove is what translates sound into touch. I like how you screenshotted the notes page instead of.
I just did it the easy way. I'm a little lethargic. Oh my god, I've had the worst and most awkwardly interrupted sleep in the last like 5 to 6 days. So I'm just kind of.
Oh, I'm sorry.
Coasting. So yeah, I'm taking all the shortcuts today.
Yeah. So.
Good.
Oh, I meant to look up exactly how the vocoder works, because that was another thing in this second class of machines.
Vocoder, yeah. What is that? Let's see. A vocoder, speech coding that analyzes and synthesizes the human voice signal for it, like an early like voice recorder, or just
Speech synthesizer, like a like like the thing that they use to simulate someone's voice when they can't speak.
Oh, like
So
Stephen Hawking kind of
yeah,
thing?
yeah.
Okay. Mm. Okay. Okay. On here. Leon Levine. A distant relative to Michael Levin, I'm sure. Our Department of Psychology.
I don't know where he was at the time, but
yeah,
Interesting.
I like that he brought up these different aspects of speech again. I forget exactly, or into something symbolic, and then you have the translation of the symbols into our meaning, our understanding of the meaning. And so this hearing glove is supposed to show how like that middle stage, there's something kind of arbitrary about it, and there could be multiple paths to the same point A to point B.
Mm-hmm.
There's something analogous, I think, in other like I'm thinking of didn't they train like monkeys to use some kind of device? I'm imagining this like experiment where they somehow handicapped the monkeys, and then the monkeys very quickly learned how to use a device that like translated information from the environment into something meaningful. I can't remember the details, but I know it was like a motor control thing. So it wasn't linguistic, like in Weiner's example. It was like a robot arm or something. So the thing, like, so the deaf person is missing the sense of hearing. And then in this experiment, what was missing was, I wish I could remember the details. That would help me explain the similarity I'm seeing. Anyways, I think there's like something analogous here in multiple areas of cognition where there's like multiple paths to the same outcome. And if you like disable this middle step, it can be replaced by something else. And with proper like feedback, you can learn how to use these tools.
Yeah, I think you said it here something like, I don't know if it's in this quote right now or not, but like how much more like for a deaf person this sight is more important in this, and I think what he meant is like because it's the feedback, like weight, like allocation of feedback, like opportunities is greater. There's not audio feedback. There's not audible feedback or audio feedback.
Right. I guess I'm thinking of like brain computer interfaces in general. Like if you have the right amount of feedback, these tools you can learn how to use these tools.
Well, and that's actually, yeah, there's something about that. Two things. Um, I'm not sure how to really break these down very well. But the Princeton Vision cyborg thing is like basically directly from what you were saying was they were the cyborg stuff was someone was experimenting with making new sensory inputs and it kind of focused on senses, but it was also the interesting part was sort of this I think a much more accurate take of what they were trying to do is exactly what you said, but it wasn't, and not that the Princeton Vision crowd couldn't have gotten that, but like I think actually a much more clear sense of what they were trying to do is not so much interpreting. It was kind of labeled as making any sense or like, oh, I like one of the persons I forget. They were sort of a 2 years in a row thing. One of them was like Neil Harbison, who was name right. This guy, he's transspecies, world's first cyborg artist. His antenna sends audible vibrations through his skull to report information to him. Electromagnetic stuff, Wi-Fi enabled antenna. He was at Princeton Vision. Color antenna here, solar crown. There's also like, I'm gonna put this here. Name. But I think I think this is actually an interesting way of thinking about what actually was going on there. Sort of like what there's in almost, I don't know if it's really fair to say informational sense, but in a controller regulatory sense, there's kind of a what do I want to call this, like channels, I guess, but I don't know. I'm sure there's some actual terminology for this in like controller communication or signal theory or something, but like it's less about the channels or making new, like part of it is making new like avenues for input, but there's also sort of like a finite space of feedback, or like not, I want to say feedback, but like actual information that the channels can convey, and swapping out or augmenting or changing the source of the input can lead to different things, but it's still sort of like I don't know. I don't really know what to say. My words are not coming out here, but there's something really interesting I'm trying to say.
Like we only have the senses that we have, but there are other ways of like encoding information and transmitting it through those senses.
Yeah. And on like there's sort of like there's almost an arbitrary amount of potential, I don't really want to say sensory inputs because that feels a little willy-nilly, but there's a non-arbitrary amount of, like, it's still only 100% of, is the signal being interpreted as yes or no or more or less, like the capacity of what the sensory input is telling or advising or influencing is still, I don't know, like I don't want to say discrete, but like there's like only like whatever the format of the signal is, the information maybe is, I don't know the right word to say, whatever the the channel of the feedback's message has a certain like, you know, amount of signal or noise or clarity or like positive or negative. And I think that's an interesting disparity between the things. If there's something I really want to write down about that, but I don't know what it is. Uh, I don't know, something like that. Maybe I can bridge more to it from the if dogs could talk thing. And I feel like an interesting like juxtaposition to this conversation is, and I said this many times, oh man, I can't find it. Like the dog that is sort of trained to press the buttons on the ground and communicate. Like the human presses, oh look, like outside, like want to go outside or whatever, and the dog will be like, oh yeah, I want to go outside. Like it will press the buttons on the ground, even if they're just not the sense that the the dog understands the language, but the sense that the dog has a recognition of this sound indicates this idea or this concept or whatever. In a sense of getting around, what's interesting to me about it is like I'm very convinced, and there was sort of a debate when I was visiting a friend a long time ago about this because I was saying, oh yeah, like to me it's super clear that you know the dog would communicate, especially some of the more sociable dogs, and the person's dog was really obviously to me like hyper socially aware, very socially vigilant, and very referencing all like who's looking at what cues, all this like like heavy social cognition stuff happening. But one of the other persons there was basically saying, oh, this dog wouldn't survive in the wild, they're kind of, you know, dumb, or they don't know how to do things, they're not tough or aggressive. And I was like, well, the person like questioning the capacity of the animal to really do anything or be anything, because it wasn't initially acting like a big brutish dog, perhaps. And it led to discussion about, you know, I think this dog would communicate a lot if it had the same means to communicate. Like it even in its current sensory setup, it's getting quite a lot of stuff. It just has a very limited means of outputting and engaging in the dialogue process. So I guess what I'm getting at here is uh, because I guess it's like in this case to me it's really clear the dog is very aware and doing like serious calculations. I remember saying to uh, it was really clear to me that the dog was basically heavily referencing and choosing like there was some serious metacognition going on about I want to convey this, I don't want to convey this, I'm going to reference this, I'm not going to reference this. And I feel like just because there's not a speech aspect of that to like confirm and announce those things, like I don't know, I could tell that was going on. So anyway, I think we're drifting a bit, but yeah. Anything we want to say also about BCI and feedbacks and things like that?
No. Yeah, let's go through the last two machines. or types of machine, I guess.
Chess player and gouverneur.
Yeah.
Right.